Hey guys, I'm Ann. And this is Jenny.
Hi, I'm Jenny.
We're going to show you how to do problems 1 through 6 on page 27 to 28. So let's begin. So we know on a compass, north is up, south is down, east is right, and west is left. And we know the center of town starts at the origin. We're trying to locate T, 5 blocks west of the center of town. If you did question 1A correctly, B and C should look like this. So now on to question 2. Question 2 requires a polar grid. Give the letter that names each point, 230, which will be at letter P. So questions B and C should look like this.
On to number 3. Give the distance and angle for point C. C is located on the second ring at 210 degrees. So C will be located at 210 degrees. So for B, point A would be located at 1.50 degrees. And for C, point T would be located at 10 degrees. To question 4! Give another way of naming 120 degrees. Since we know that the whole circle is 360 degrees, and we're trying to locate -120 degrees, then find the positive number of that, which is 240 degrees. So if you did A correctly, B, which is 300 degrees, and C, which is 180 degrees, will be B as 2-60 and C as 180 degrees. For question 5, you require some graph paper, a protractor, and a centimeter ruler.
A point is given in the grid system. What would it be called in the distance angle system? So let's first locate point 34.
According to the Pythagorean theorem, in a right triangle, the square of the legs is equal to the square of the hypotenuse, which is basically a squared plus b squared equals c squared.
3 squared plus 4 squared equals c squared. 3 squared is 9 and 4 squared is 16. Then the hypotenuse will be 5 because 9 plus 16 is 25. Use a protractor and measure the angle of the triangle. So the coordinates will be 553 degrees. So B will look like this. C will look like this. And D will look like this. The last question is number 6. A point is given in the distance angle system. What would it be called approximately in the grid system? Hint: measure the sides of the triangle. For this problem, you'll need to know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. First, we'll solve for side x. Sine 50 is x over 2, which is opposite over hypotenuse. That turns into 0.7660, which is equal to x over 2.
X then turns into 1.532, which is about 1.5. Next, we'll solve for y. Next, we'll solve for cosine 50, which is y over 2. That then turns into 0.6428, which is equal to y over 2. Y then turns into 1.2856, which is approximately 1.3. So B will look like this. C will look like this. And D will look like this. In real life, say you are an airplane pilot being chased by another pilot. He's shooting a missile at you. You are at the origin, and you need to avoid the incoming missiles. Your plane uses a polar grid to locate the missile. You see it on your screen. You swerve and avoid the missile. For example, if the missile is over here, and you are at the center, try to find the missile before it hits you so you can avoid it. You know that the missile is located here. You first need to locate the ring where the missile is. It's on the second ring. Looking at the graph, we see that the missile is at negative 60 degrees. You know the missile is at negative 60 degrees. And that's how you solve numbers 1 through 6 on page 27 to 28. Thanks for watching!